Hello, Integrated Math 1. Welcome to lesson R.7-2. We're going to be talking about substitution today. We're still dealing with systems of equations, but we have a new method for solving them. So before we get into that, let's just do a little warm-up. I've got two equations here. For the first equation, I would like you to solve the equation for x. For the second equation, I would like you to solve the equation for y. So a little bit of a throwback to the last unit. So go ahead and hit pause, solve each of these for the given variable, and then hit play when you're ready to check your work. All right, you ready? You ready? So let's talk about equation number 1. I want to solve the equation for x. I need to get the x alone, so I'll start off by subtracting both sides by 5y to move it over to the other side. So I have 4x equals negative 5y plus 16, or you could have written 16 minus 5y. Both ways of writing it are totally fine. Of course, I do need to divide everybody by 4 if I'm going to get that x all alone. Oh, sorry, that went weird. My bad. So I have x equals negative 5/4 y plus 4, 16 divided by 4 being 4. Yay, and there's my answer. And let's head on over to the other one. So for the other one, we want to solve for y. I want to get y alone. So I'm going to go ahead and add x to both sides just to move it out of the way and to the other side. So I now have negative 5y equals x plus 12, or you could have said 12 plus x. Both ways of writing it are, of course, correct. And then I'm going to divide everybody by negative 5. Just to make it a little more manageable, you're welcome to put a 1 in front of your naked x. That is, of course, always an option. So those cancel out. So I have y equals negative 1/5 x. Positive divided by negative is a negative. And 12 divided by negative 5, well, let's just leave that as a negative 12/5. I guess if I really wanted to, I could say that that's 2.2, or I don't know, I could do something with it. But for now, I'm just going to leave it because it's fine just the way it is. No big deal. All right, so as always, guys, we were just saying, we're doing substitution today. So last time we solved systems of equations by actually graphing them, because that's the whole idea. The solution to a system of equations is where the equations intersect, where the equations of the lines intersect. Yes, where the lines of the equations intersect. But there are other ways to solve systems of equations. So the way that we're going to be playing with today is using what we call substitution, and it's pretty straightforward. The idea is that if you want to solve systems of equations by substitution, then your first step is, when necessary, solve at least one equation for one variable, right? Just on that last, on that warm-up, we solved the equation for x, and then we solved the equation for y. So you want one of your equations to be either just x equals or just y equals, so that you can then do step 2, where you can substitute the resulting expression from step 1 into the other equation to replace the variable, then solve the equation. And if that sounds confusing, once we do it, you'll get the idea. Now, once I've solved the equation and I have one variable, well, that's great. But remember, a system of equations has two equations because it has two variables. So we need step 3, where we substitute the value from step 2 into the other equation. Into either equation, actually, it really doesn't matter which equation you plug it into, and solve for the other variable. And then we'll write the solution as an ordered pair. So here's the trick of this. It's actually not hard. It's a lot of old stuff that you guys have done before, a lot of solving equations. The only thing is, remember that you have to find x and y. You have to find both of them, because remember that your answer is a point. Your answer is an ordered pair with an x coordinate and a y coordinate. So it's super important to make sure that we get both of those. So I'm going to show you what I mean. All right, I'm going to help y'all out with example 1, and then I'm going to make you do some of these, okay? So we're going to use substitution to solve the system of equations. Now, step 1 said that we need to isolate a variable. Well, look how convenient this is. Look how convenient this is. We already have a y equals. That's awesome, because this means that everywhere I see y, I can substitute 4x plus 11. Oh. So I can take this first equation. So I'm going to go to the other equation. And I'm going to say, okay, 3x minus y equals negative 7. Except, instead of a y, I can substitute in 4x plus 11. So that's what I'm going to do. So I have 3x minus, instead of y, 4x plus 11, and I use parentheses there, equals negative 7. Now, there are a couple things we have to do. First of all, it is important to distribute that negative. So I'm going to distribute that negative. That means that's still going to be 3x, but that's now negative 4x and a negative 11, and it still equals negative 7. Awesome. Oh, we have like terms. My x's are on the same side, so I have 3x minus 4x, which is minus 1x. I just put minus x, but if you want to put minus 1x, that's okay. I still have negative 11. I still have a negative 7. Yay. Ooh, I need to get x alone. So let's go ahead and add 11 to both sides. So those will cancel out, which is why we did it. Negative 7 plus 11 is a 4, right? Yeah. So I have negative x equals 4, except I don't want negative x. I want a positive x. So again, if you think of that as a negative 1x, you could just divide both sides by a negative 1. So those cancel out. Ooh, sorry, the lights get so dark in here. So it's a positive x. 4 divided by negative 1 is a negative 4. Hooray! So you've actually done the worst of this. You have found what x equals. But remember, we also have to figure out what y equals. So we're cool. I know that x equals negative 4. So everywhere I see an x, I can substitute in a negative 4. And you can use either equation. I'm going to use that second one, that y equals 4x plus 11, because it just seems easier. So instead of 4x, I'm going to do 4 times that negative 4, right? We're going to substitute that in. Of course, 4 times a negative 4 is negative 16. Negative 16 plus 11 is a negative 5. Yay. So I have my 2 answers. Now, we've done beautiful work. We don't want to mess it up on the final stretch, on the easy part. Remember that our answer is a point. Remember that our answer should be written as an ordered pair with the x-coordinate first and the y-coordinate second, right? So the solution, it looks like my x-coordinate is negative 4. My y-coordinate is negative 5. So it looks like my solution is negative 4, negative 5. Yay. So that wasn't so bad. Not bad at all. It's a lot of steps, but you know what? There's nothing new here, right? We know how to substitute stuff in. We know how to solve an equation for a variable. We know how to do all of this. So let me give you another example, and I'm going to challenge you to play with this one a little bit, okay? Don't forget step 1. Example 2, again, I would like you to use substitution to solve the system of equations. Don't forget about example 1. So go ahead and hit pause. See if you can work your way through this. And then hit play when you're ready to check your work. Okay. So the issue here is I don't see like x equals or y equals, right? We don't have an isolated variable. But I'm looking at this second equation because I notice that my x has a coefficient of 1. We don't usually write the 1 there, but I could put a 1 there if I wanted to. What this says to me is that this equation is going to be really easy to get the x alone. Yeah. So because x has a coefficient of 1, I'm thinking that's easy to get x alone. So I'm going to go ahead and solve for x. All right. So that means I am going to subtract 4y from both sides. So those will cancel out. That's why we did it. And now I have x equals 18 minus 4y because those are not like terms. But now we can do what we did on the last problem. So this one did have an extra step. We did have to deal with step 1. We kind of glanced over step 1 on the last problem. This one, we had to deal with it. But that's no big deal. Now I know everywhere I see an x, I can substitute in 18 minus 4y. So I'm going to go to the first equation, and instead of 5x minus 3y, I'm going to do 5 times 18 minus 4y minus 3y equals negative 25. So all I'm doing is I'm just substituting in for x. Instead of an x, we're substituting in 18 minus 4y. And now you totally know what to do, right? We need to distribute. Oh my gosh, and this is why I have my calculator, because got to be a bit much. 5 times 18 is 90, and 5 times negative 4y is negative 20y. Now I have my like terms, so negative 20y minus 3y gives me negative 23y. So I have 90 minus 23y equals negative 25. I'm kind of running out of space, so I'm going to end up moving it up here. I want to get the y alone, so I'm going to go ahead and I'm going to subtract. I don't want subtitles. How do I turn them off? Nobody knows. That's how you do it. I found the button. So I'm going to go ahead and I want my pen back. Give it back. I'm going to go ahead and subtract 90 from both sides, minus 90 from both sides. Sorry for the bad writing. Of course, these will cancel out. I mean, that's why we did it. That was the whole point and purpose. Negative 25 minus 90 gives me negative 115. I had to write it up here. Sorry, I was running out of space. And to get our y alone, I'm going to subtract negative 23 on both sides. Not subtract, sorry, divide. I'm going to divide negative 23 on both sides. And this is why I have a calculator. So these cancel out. Negative divided by negative is a positive. 115 divided by 23 is 5. All right, we have done the worst of it. The worst of it is over. I have one solution. I have one value. I need the other half. So I don't care which equation you pick. Just pick one of them, and everywhere you see a y, ooh, where's my mouse? There we go. Come back, baby. Everywhere we see a y, we're going to substitute in a 5 for our y. And again, you can use either equation. I'm going to use that second one. It just, I don't know, feels like a choice. So instead of 4 times y, I'm going to do 4 times 5. Of course, 4 times 5 is 20. And if we subtract 20 from both sides, I find out that x is a negative 2. Please remember that your answer is an ordered pair. And please remember the x-coordinate always comes before the y-coordinate. So it looks like my x-coordinate is negative 2. And it looks like my y-coordinate, there it is 5. Boom. So the solution is negative 2, 5. Nice. Nice. And you also got that entertaining moment of me accidentally activating the subtitles and then figuring out how to turn them off. One more. I have one more. Una más. Yeah? Example 3. We're on page 401, by the way, if you're not sure where we've been wandering off to all this time. I do have the page numbers up in the corner. All right. So again, I would like you to use substitution to solve the system of equations. Hit pause to work it out. Hit play when you're ready to check your work. Remember that step 1 is that we need to isolate a variable, right? No problem. Look at that. I already got a y equals. That bad boy's already isolated. Yeah. So that means everywhere I see a y, I can substitute negative 2x minus 4 for y in the equation. So we'll do that in the first equation. So instead of 4x plus 2y equals negative 8, I'm going to say 4x plus 2 times negative 2x minus 4. Great. All right. Okay. So now I'm just going to distribute, right, because we don't want that happening. So I have 4x plus negative 4x minus 8 equals negative 8. Oh. 4x minus 4x is 0. My x's cancel out if I combine my terms. I have -8 equals -8. We've had this happen before, haven't we? This has happened before. This tells us something. Guys, -8 equals -8, that's an identity. That's an identity. Do you remember? Okay, do you remember? Maybe you remember from last time, maybe you remember from our last unit. I don't know, but do you remember that this means that there's an infinite number of solutions? Oh, okay. That darn light. There we go. Back in. So you can say infinite number of solutions, or I think the way we were phrasing it last unit is we were saying that there were infinitely many solutions, right? Something like that. Yay. Awesome. And from a graph perspective, that means that's a situation where where they're the exact same line, right? Where they'd be like right on top of each other. So we're not foreign to this concept. Well, as always, guys, I hope you found this helpful. I hope you found this useful, and I'm sure there were a few entertaining bits along the way. If you have any questions, you need something, just come talk to me. I'll help you out, and I'll see you guys later. Bye.